Hello and welcome to this video, which is about solving ratio problems using the bar method. I'm an experienced teacher and I'm going to show you how to do it and how to teach others how to do it. The bar method is not a method for calculating, it's a method for understanding, and we're going to just get straight into it and have a look at some problems. Divide £60 in the ratio 2 to 3. So what you're going to do is you're going to draw a bar, and that bar represents the amount of money, in this case, that you have. And we're going to divide it up into 2 orange blocks and 3 blue ones. And the important thing is that each one of these blocks is exactly the same. So that's 5 blocks in all. So the whole thing is worth £60. So that means that each block must be worth £12. Then once you know that each block is worth £12, all you need to do is to add the 2 12s to get 24 and to add the 3 12s to get 36. And there you have it. We're just going to quickly check. Does 24 plus 36 equal 60? Yes, it does. So that's your answer. If you divide £60 in the ratio 2 to 3, it's £24 to £36. Let's have a go at another one. This one's a little bit different, but it's not any more difficult. In a paint mixture, the ratio of blue to red paint is 3 to 1. So you're going to make sort of purple paint. You have 40 litres of red paint, and how much blue paint is needed, and what is the total amount of paint that is made. So we're going to draw the bars out again, but we're going to draw 3 blue and 1 red because that's what the ratio is. We don't know what the total amount is at the moment, but we do know that the red is 40 litres, and we do know that each block is exactly the same, which means the 3 blues have to be 40 litres each as well, which means the total amount of blue must be 3 lots of 40, which is 120 litres. And the total must be 160 because it's 120 litres of blue and the 40 litres of red. Simple as that. Let's up the level of difficulty a little bit, but it's still doable. A school allocates its annual sports and technology budget in the ratio of 5 to 3. If £12,000 more is spent on sports than on technology, how much is allocated to each? I think this is where the bar model really comes in to its own. So we're going to draw our bar, and we're going to draw 5 blue, and that's going to represent sports, and 3 green, and that's going to represent technology. Now it's not necessarily completely clear what to do at this stage, but what I'm going to do is I'm going to bring the technology down here so I can compare the 2 bars, because then it's obvious that these 2 light bars must be the £12,000. And if it's £12,000 for the 2 of them, it means that each one must be £6,000. And if that's £6,000 each, then the other blue ones must also be £6,000. And come to think of it, since all the bars are the same, the green ones have to be £6,000 as well. So now we can say that the total sports budget is 5 lots of £6,000, which is £30,000. And the total technology budget is 3 lots of £6,000, which is £18,000. And final example, this one is for GCSE. It's a higher level question. In a school, the ratio of girls to boys is 2 to 3. 25% of the girls have school dinners, 30% of the boys have school dinners. What is the total percentage of students in the school who have school dinners? So yet again, I'm going to draw my bar. I'm going to draw it with 2 blocks for the girls and 3 blocks for the boys. And this time, we don't know how many students there are in the school. But because this is a percentage question, and because percentages are basically just fractions, it doesn't matter how many students there are in the school. So I'm going to choose each one of these blocks to have 100 students in. You might make another choice and make the whole school have 100 students in, and that would work actually, because we've got 25% and 30%. But my method will allow you to do 23% and 32%, no problem. So I'm going to have 100 students in each block. And that would mean there'll be 500 students in my make-believe school. And I know that 25% of the girls have school dinners, which means that 25 out of 100, so that's actually 25 girls in that first pink block and 25 girls in the second one as well. And then it's 30% of the boys that have school dinners, so I'm going to put 30 in each of those blocks. Now I'm going to see how many students in total have school dinners. It's 50 plus 90, 50 girls and 90 boys, and that makes 140 students in all. And then I can just write it out as a fraction. That's 140 out of 500. But the question has asked for percentage. So for a percentage, I need the denominator to be 100, and I can achieve that by dividing the 500 by 5, and whatever I do to the bottom, I must do to the top. So I'm going to divide 140 by 5. 140 divided by 10 is 14, so 140 divided by 5 must be 28. So the answer is 28%. So there are all the examples I'm going to give. I'm just basically showing you that by using bar models, it just makes these questions which otherwise would be pretty tricky to solve, it just makes it easier to visualize what's going on. And once that's the key thing, because the actual calculations are pretty straightforward. So once you can work out what it is you need to do, then you can work it out quite easily using bar models. So if you've not used bar models before for ratios, give it a go, see how you get on.